Now gives me great pleasure to introduce Jamie. So Jamie is a Google developer expert for Android and a tech lead for Sharesies. He started out by hacking early Android devices to run custom ROMs, moving into the professional app development space in 2015. To guide us through what's new in the Android testing space, please welcome Jamie Sanson.
Good. Awesome. Cheers for that, Aaron. So hey, g'day everyone. My name's Jamie, as Aaron's mentioned. I'm super stoked to be here just before we get into the talk. This is my first in-person conference talk since 2019, really, so it's really exciting to see the whole conference just be packed out with this many people. Today we're going to be exploring the current state of testing in Android. Things have improved dramatically over the past couple of years, and really in the 14-year history of Android, we're starting to reach some of that sort of maturity land where the platform really isn't changing a huge amount, but things are just getting better and better for companies that are able to scale up. A disclaimer before we start, I'm predominantly going to be talking about native Android, but a lot of these things can be utilized by people who are potentially working on cross-platform things, so keep an ear out and we can chat about it afterwards if you have any specific questions. Now, before we get into talking about some of the new hotness in Android, I figured it'd be kind of interesting to take a high-level walk in the park and look at what old Android used to be like. Cast your mind back to 2010. Back around here, Android was only 2 years old. The current and kind of latest version of Android was Android Eclair, which was 2.1, and API level 8 for the developers in the room. And back then, apps were super basic. They were really heavily leaning into system components, so things like activities, services, and really leaning into broadcasts and things like that, and not doing too much outside of the norm. Way back then, JUnit testing existed. It's sort of been there forever, and it's kind of the de facto unit testing standard for any kind of Java-based application. And instrumentation testing kind of existed. So it was there. It was bundled with the platform, though, and it was really tightly coupled to the app itself. To see what I mean by this, let's take a look at a test from back in 2010. For a bit of context, this is the Samsung Galaxy S, the original, no numbers there. That came out in 2010, ran Android Eclair. And on the right-hand side, you can see what an instrumentation test from back in 2010 used to look like. Without going into too much detail, you can see that it's using some pretty view-centric APIs. It was pretty much using the exact same APIs you'd be using to build your apps, but then it would give you access to this thing called an instrumentation. And instrumentation is something that sits kind of right in the middle of the fundamentals of Android. It's right in there in the view system, and it allows you to keep track of what the system itself is doing. When you are writing these instrumentation tests, you'd use the view APIs that you do to build the app itself, plug into the instrumentation, and wait for things to happen before continuing on with your test. Let's jump forward a couple more years. Jellybean, so API 16 and Android 4.1 was sort of the latest Android version around this time. And apps were starting to get more complex. So notably, one of the sort of larger apps that came out around this time was Snapchat, which released in late 2012. As per usual, JUnit tests were there. Nothing really changed. Nothing ever changes with JUnit. But because of the fact that instrumentation testing was so coupled to how the apps were built, there was this real want for something that wasn't as coupled to the app itself and allowed you to do things outside of the context of your app as well. And that's when this thing called UI Automator came along. UI Automator is this tool that allows functional cross-app testing. And the really big part here is that it's decoupled from your app. So as for a bit of context, here's what devices look like around that time. You can see the screens are getting a little larger, the text is getting a little smaller, and hollow design is out and about, one of my favorite kind of eras of Android. But again, on the right-hand side here, you can see what tests used to look like back then. And this is making use of UI Automator. The main thing that you can see here is instead of actually plugging into the views themselves, it's using sort of more broad descriptions to look for the thing to interact with. You can see right at the top here, we're getting access to something called a UI device, which kind of models the entire device as a whole. we're interacting with the home button, and then we're looking for an object with a description called apps. This will probably be in the launcher of that device, so kind of like the app drawer. And then we're clicking on that thing and waiting for something to happen. So you can see there's a little bit of built-in synchronization, but it was very, very high level. And kind of the key shortcoming here is that it didn't actually allow you access to any of the internal state of your app. So if you wanted to test against things within the app itself, you couldn't really do that with UI Automator. 2 more years in the future. Android Lollipop was the kind of current version of Android at this time. API 21 and Android 5, apps were getting even more complex around this time. But this update was pretty huge, and a lot of things happened in 2014. The massive UI refresh to Android happened, which brought Material 1.0. And our developer tooling got so much better than it used to be. Android Studio came out kind of in a beta version in the earlier years, the start of the year, and went full release at the end of the year. And that brought new and much improved just tooling for actually building your apps. Again, JUnit tests don't change too much. UI Automator, it's out there, people are using it, hasn't changed that much. But now that niche or that area where you wanted to do single app tests is something that was taken up with this new framework, which I'm sure some of you will be familiar with, called Espresso. Espresso is a functional single app test framework. And one of the other key selling points here is that it has built-in synchronization. And again, let's have a look at some of the devices from that time. So here you can see that this sort of suite of devices that Android supports started to expand a bit. You can see that multiple form factors are using the same kind of UIs. And that little puck-looking thing there was sort of a precursor to Google TV or Android TV. And then on the right-hand side, you can see what Espresso tests look like. Here you can see that they're not directly coupled to the app anymore, and kind of force the separation of actually doing your sort of arranging, acting, and asserting like you would with most other tests. So at the top here, we're finding a view, and again, we're using IDs, so we are still referencing things from within the app, but we're being much more lenient on how we match it. We don't really care whether or not that thing's a button or a bit of text that's clickable. We just know that we're looking for an ID, in this case with change text button, and performing a click action on it. After the fact, we can then look up some other view and then check that it matches the assumptions that we're sort of making. And that's what an Espresso test still looks like to this day. So from there on out, testing in Android didn't really change a huge amount up until a year or so ago. Espresso, UI Automator, and JUnit saw gradual uplift. We can now use sort of later versions of JUnit. And Espresso got a few new APIs to fit with some of the newer kind of view components that came to Android. But these fundamentally didn't change for more than 6 years. But things have changed, and the pace of Android continues. The ecosystem has changed dramatically since 2014. So let's take a look at it. First up, building apps has changed pretty considerably since then. We've seen changes to language, we've seen changes to our tooling, and also computing. One of the really big things that's happened between sort of 2014 and now is the introduction of this brand new language called Kotlin that is now sort of the norm for building Android apps. This allowed us to pretty much eliminate an entire class of errors to do with nulls, and also allows us to write much less code in the process. As well as that, the way in which our apps are actually put together by our build tools is getting more and more optimized. And what this has kind of allowed us to do is not only run our builds faster, but structure our apps in such a way that we can have multiple teams working on them without having a conflict and stand on each other's toes. Additionally, as I mentioned, computers just keep getting faster and faster. The M1 Max that came out a couple of years ago sort of revolutionized the mobile development community just due to the fact that we can do builds so much more faster than we used to be able to. And tooling improvements have come out over the past wee while, which are shortening those development loops. One of probably the most major tooling improvement that have changed in Android is the introduction of this thing called Compose UI. This is Android's new modern toolkit for building native UIs. It leans into Kotlin and allows us to write considerably less code when we're actually writing the view side of things in our apps. while also being able to write those things faster and in a much easier to read way. The main difference here between Android's view system and what you're seeing here is instead of telling the view how it should look precisely, all we need to do is describe the view and let the system handle itself. And you can see from reading through some of this code here, there's a card that kind of wraps the outside. There's a column, so it lays out things in a column. There's an image at the top and some text at the bottom. And then looking at what it actually produces, it's pretty self-explanatory. And kind of the other major change that is kind of spurred a lot of the changes that we're going to be talking about shortly is that Google have sort of changed their stance toward testing in Android. They're really showing a much more concerted effort at making Android testing better, aiming for more test coverage over every app in the store. Here's a quote from Aruf Sinocho, who's in the Android Studio team at Google. We'd like more Android developers to be writing more tests. The context behind this is that the teams that actually build the developer tooling, so Android Studio, via anonymized metrics, know the proportion of developers who are writing and running tests. Now, although they haven't shared those numbers, they've pretty bluntly said it's nowhere near as much as they'd want it to be. So there's this really concerted effort to make testing easier, faster, more accessible. So, with all that context in mind, what's new in Android? First up, we've got this thing called Unified Testing Platform. The platform's dropped off there, but Unified Testing Platform. Unified Testing Platform is this component for Android that was introduced at Android Dev Summit in 2019, originally as something known as Project Nitrogen. It addressed two major issues with how tests are run in Android. First up was this kind of interesting little bug that developers probably came across, and it's that running tests in Android didn't actually used to be consistent when you were running them from your dev machine or CI. When you were running your tests from your IDE, it would run through one sort of orchestration pipeline, and then if you were running your tests from the command line, like your CI would be doing, it would use a completely different orchestration pipeline. And what that meant is you'd get inconsistencies. If things were green on your machine, they're not necessarily green on CI. One of the big things with Unified Testing Platform is that it's unified that. So now all the way in which we run Android tests is the same regardless of where you run it from. But the other major kind of fundamental change with Unified Testing Platform is the support for host and client plugins. Now, when I say host and client, by host I mean the computer that's running the tests, so actually orchestrating that, and the client is the device that the tests are running against. Unified Testing Platform allows you to effectively write code and plugins that sit on either side of that kind of communication barrier. So let's talk about one of those plugins, Gradle-managed devices. So Gradle-managed devices leverages the Unified Testing Platform APIs to make spinning up and sharing emulator configuration as easy as possible. It allows you to define your emulators as code and manage it via Gradle, so checked into source control, rather than having to ask your developers to all have sort of the same version of the emulator installed on their device, as well as have that configured in CI. And this is an example configuration. So you can see it's relatively basic. We have a managed devices block, and within that, we can define as many devices as we want. Here, we're defining a Pixel 2 at API 30. So we can say which device profile we want, which will be the same as the devices manager in Android Studio. We can then choose the API level that we want the emulator to be, in this case, API 30. And we can choose what system image we want to be using for that emulator. And we have a couple of choices here. So AOSP is relatively slimmed down. It's Android without any of the proprietary Google stuff. But if you need that Google stuff, you can swap out AOSP for Google. But one of the other things that the Android development team were really keen to focus on is allow you to kind of get more bang for your buck with your tests. And one of the things that is going to help do that is lighter weight and faster emulators. And that's where automated test devices come in. These are lightweight emulators that are specifically built for automation tests. They do this by stripping out a bunch of different system services that you don't need normally. So things like wallpaper managers and I guess Wi-Fi drivers and things like that. And in doing so, They minimize the amount of resources the emulator actually takes to run. They decrease the boot time. And in doing so, you can run more and more of these sort of side by side. One thing that's worth noting here, though, is one sort of way they get around making things faster and easier is to not rely on hardware rendering, so there's no like GPU contention going on. But what that means is that if you're trying to do screenshot testing, for example, and the code that you have in your app relies on hardware rendering, these aren't a great choice. Now, to make use of those automated test devices and the fact that we can run sort of more of these on our machines at once, this other introduction of this feature, of a couple of features called test matrices and sharding. And what test matrices, first off, allows us to do is define kind of a group of devices that we want to run our tests against. And what that allows us to do is pretty much just span out our tests to a bunch of different devices and ensure that we have coverage over kind of all the different types of devices that are out there. You can also have multiple of these device groupings. So in a little bit of code here, you can see that we have a phone and tablet group that we've created. And using those devices that we kind of set up previously in the Gradle-managed devices block, we can plug these into target devices for that group. So here we have a phone and tablet group, and that's got a couple of devices in there, a Pixel 2, which is a phone, and a Nexus 9, which is a tablet. But you can really just do whatever you want with these. You could have tablets across varying different API levels. You could have multiple different types of phones in there, whatever you want, really. And then to sort of improve the sort of run times of our tests, there's now also support for sharding, which effectively means you can split your test suite up into however many shards as you want. So say you had 10 tests, you wanted to shard it twice, 2 shards. It'll spin up sort of 2 instances of the test orchestrator and run 2 sets of 5 tests side by side. What that means, though, and something to be careful about, is that when you're using sharding and matrices together, that's a multiplicatively complex thing, which means if you've got 5 devices in your device group and you're sharding it twice, you've now got 10 emulators running on your machine, which can tank your computer pretty quickly. And then one final improvement to emulators that are trying to make things faster and much more reliable is the introduction of emulator snapshots. Now, these things have been around for a wee while, specifically in development land, to make it easier for developers to spin up an emulator when they want to try their code against a device. But now introducing these for testing has a bunch of different benefits. So it now makes emulators even faster to boot for automated testing, with less memory footprint because you don't need to spin up the entire stack. You just sort of plug in the memory that was in use by the device at the time. But really the key improvement here is it provides you a clean and repeatable state for emulators during tests. So you know exactly kind of what snapshot you're sort of restoring from for every single test. Another really interesting feature here is emulator snapshots allows you to restore the exact device state of that device when a test fails, or from slightly before the test failed. And what that allows you to do, if you've got a flaky test, you can grab the snapshot from when it was flaking, load it up into your IDE, drop it on a device, hit a breakpoint, and see specifically what in the app is causing that to be flaky. Cool. We've talked about Compose a little bit, but with Compose as a new UI framework comes a new UI testing framework. Now, UI testing in Compose largely keeps a lot of the old kind of paradigms that we're used to with Espresso around, but still introduces a bunch of new and exciting things. So it does introduce a suite of new APIs for UI testing with Compose, and these are built to be faster, more reliable, and harder to mess up than Espresso or UI Automator. But the team at Google are kind of wary that not a lot of apps out there are entirely Compose-based. So these tools need to be interoperable with the things that are already there, so Espresso and UI Automator. They're easily usable inside hybrid apps, so you can run these sort of testing frameworks alongside Espresso, and you can even make use of it in UI Automator land through sort of semantics. The other really interesting and exciting thing with UI testing in Compose is that because Compose itself isn't part of the operating system. It's bundled with the apps that use it. It allows the testing frameworks to be able to plug in much more comprehensively to how those tests, so how the app itself actually runs. Because of that, the tests are automatically synchronized with Composer's runtime. And because the frame clock itself is unbundled from the system, you can actually have tests that run faster than real time while still instrumenting all the code paths that you normally would have. So let's look at a quick example to show just how similar it is to Espresso. First up, one of the interesting things that we can do with this, this new Compose UI testing sort of suite is we can actually test flows in isolation. Here we have a main screen, which, I don't know, might just be a screen with some sort of state. And we're saying that we only want our test to look at that specific screen. We can then use pretty similar APIs that we might be familiar with from Espresso to find things within that Compose view that we've spun up and do things. So the main difference here is you'll see that APIs are called on node with text rather than on view with text, which is just a slightly more generic paradigm used to Compose. But for the most part, there's almost a one-to-one mapping of Espresso matches to Compose UI testing matches. Again, we can perform a click, and then the sort of transitions and things that happen after that click are automatically synchronized with the framework, which means we can continue on straight away and assert on the visibility of the things that we expect to be there. Another interesting thing I figured I'd touch on very briefly is that third parties are starting to produce more and more kind of like testing frameworks and libraries to enable us to test more things in a more scalable way. And that's where snapshot testing with this library called Paparazzi comes in. Paparazzi is another industry-changing library from the Cash App / Square developers who do pretty much everything else for Android. And it's this really interesting library that takes the rendering system from Android itself and bundles it into a library. And what that means is if you want to take your views or your composables, render them and then dump them out to like an image, for example, you don't need to spin up an emulator for that, and you don't need to worry about differing hardware as well, because these are all running within the context of your unit tests. There's this other library that's also come out specifically kind of tied to Compose more so, and it's this thing called Showcase. Now this came from Airbnb, and it's a way of kind of automatically spinning up a catalog for your UI components within your app. So say you have a design system and you have a bunch of components for that. By using Showcase, you can pull together all the developer previews that have been built for those components and show them in some UI within your app. If you combine the sort of collating of all those previews with this, this sort of snapshot testing library, you can automatically get snapshot testing wired up for all of your UI components in about 10 lines of code. A quick example of what a preview might look like and then the sort of generated image is this. And this is from the Now in Android sample from Google. There's a link there which you should be able to click in slides at some point. But you can see that we've got a preview, we name it something, and it's a composable as well. So this looks pretty much exactly the same to what our actual UI composables would look like. But again, we're just isolating the single thing that we want to actually preview. And then with that combination of Showcase and Paparazzi, we can generate these images. So on the right, you can see what it would actually look like. And then because these are so quick and easy to run, you can run these in CI and compare the differences between images. Cool. So there are a few things, obviously, that we've seen that Android are doing to try and make Android testing in Android much easier and much more scalable. But they're not done yet, and I figured I'd talk a little bit about some of the things that I could speculate on with what might be coming next. First up, I think snapshot testing is something that Google are thinking about, but they haven't done yet, which, as you could see from the slide previously, third parties are kind of jumping on and trying their hand anyway, because it's clearly a problem that needs to be solved. Google already have really good internal tooling for snapshot testing, and specifically snapshot testing management. So if you're If the new images from your branch don't match with the golden, you then need to go and do a bit of work to say, okay, is that wrong? Should I update the one that's on kind of the main branch, or is there an issue with my code that I need to go fix? And kind of the key thing with snapshot testing is to make them as lightweight as possible. You want to be able to accept that new change as easily as possible. And Google have supposedly internally a bunch of sort of developer tooling to allow that to be seamless. Additionally, I think because Compose is relatively new, there's still quite a bit to be done in the testing space there. Notably, not everything is synchronized within the Compose runtime at the moment, specifically coroutines, which means that if you're doing asynchronous stuff, that won't automatically kind of marry up to your tests that are expecting it to. That is something that's coming soon, but there's still a bunch of other little bits and pieces that would be really useful to have. Notably, scrolling isn't very good either, so that's happening. The other thing I think we're definitely going to see is more and more of these unified testing plugins. I wasn't able to find any third-party examples of these, but I think that's probably not going to be too far off. And I also think because the system itself is so powerful, Google are definitely going to be adding more and more of these plugins for developers to use. And finally, just speed improvements. It's kind of a, Moore's law. Things keep getting faster, machines keep getting faster, but also what we've seen from how the apps themselves are run and the sort of progression over the years is that build times are getting faster, our build systems are getting faster, and that's something that's going to continue. Cool. So to conclude, Android has come a huge way in the past decade from really kind of basic, really tightly coupled testing to things that now allow us to run them across multiple devices really easily with a bit of lenience and built-in synchronization. In general, things are getting quicker and easier, and I think that's a trend that's going to continue in Android, specifically in testing. Google really cares about app testing, and they've said that they still have more to do, so I think we're going to see quite a bit more over the next couple of years. But really kind of what this all rounds out to is that testing in Android at scale is now much more manageable than it used to be just a few years ago, and this is going to continue as well. Awesome. Thank you very much.
Awesome, thank you. Now we do have time for questions. Remembering if you want to ask a question, you're going to have a brick thrown at you. Are there any questions? Here's one. I'm a cool, are you talking?
Thanks. So my question is, I'm quite new to control testing, and I do heard some platform approach like Osmos controls and also Osmos manufacturing. What's the difference between this platform and the one you
Great question. So just repeating the question for people who didn't hear and for the recording. The question was, so native Android exists. We have Espresso, we have Compose UI testing. There's also a bunch of other kind of third-party frameworks for doing our instrumentation, things like Appium, and sort of how does that all fit in. I think they kind of operate side by side in a lot of ways. So a lot of the sort of third-party testing frameworks do make use of new Android APIs when they come out. Specifically, that instrumentation thing that we saw right at the start is kind of fundamental to those testing frameworks. And I think what we're going to see is that these testing frameworks are going to make use of some of the newer APIs that have been released as well. So with managing devices and things like that. Under the hood, they're probably going to be using these kind of nicer, newer APIs just because they get so much for free from it. So yeah, that's kind of how I see it.
Fantastic. Are there any other questions? There's one. Cool. Do you want to throw the brick over? Yay!
So talk about running tests on physical devices as well as being able to run tests without physical devices at all decoupled from the Android system. We would use one over the other in terms of like setting the pipeline.
Great question. So yeah, the question again is, we now have the capability.
That was my fault.
We now have the capability to run tests without having Android devices kind of in the pipeline, but we can still run them with devices. So kind of where do they fit? Like where would you use one over the other? So I think the sort of testing where it's decoupled from the system itself, because there's so many speed improvements there, I think it makes sense to put that in places like CI, where you care about kind of coverage and quality for the code that you're getting into your kind of trunk branch, so main or development, depending on how you do it. And by being decoupled from Android, these things can run super quickly, so you don't need to slow down that pipeline too much. But then when it comes to sort of running those end-to-end suites that you might have built up, that's where having devices or fully fledged emulators as opposed to those automated test devices might make sense, just because it sort of allows you to instrument the whole stack of Android rather than just kind of the rendering bit, just in case there's things that on the device that might interfere with sort of how your tests are supposed to be run.
Awesome. That's all the time we've got for questions. Join me in thanking Jamie once again.